we move on now into lesson 4.5, direct variation, here's what our learning goal is. We have to be able to identify when a linear equation is representing direct variation. We have to be able to write our own direct variation equations. And we have to understand what the graph of a direct variation equation should look like. So direct variation is linear, so you should have a line. But it has a special characteristic that the other linear equations, functions do not. So when a linear equation is written in standard form, what's standard form? We learned that, you learned that back in, right at the beginning of the chapter, lesson 4.1. What's a linear equation in standard form? Anybody remember it? It's been a while, just like last year. Pardon? F of x, now you're saying function notation. Okay, let's just look down right here. Why don't you circle this, you guys? Here's, whoopsie, I need a pen. Right here, in the next, that right there is, well, actually standard form has a c at the other end. So it's ax plus by equals c. So, you know what we'll do? Is we gotta have that c there. Let's put it up above here. Ax plus by, capital A, little x, plus capital B, little y, equals c. That is really standard form. When the x's and y's are together on the same side, not being multiplied, remember that? Not being in a denominator, not being taken to a power, not being in a power. All those things were parts of linear functions, and then set equal to a constant. So when it's in standard form and that c is 0, that constant is 0, it is a special linear relationship called direct variation. So when you have a linear function, that when you can put it in, when you put the x's and y's together on the same side, and the constant it is set equal to is 0, you say it is a direct variation. But rather than being written as, leaving it as ax plus by equals 0, where, by the way, a and b cannot equal 0, or we don't have a direct variation. Here's how we're going to write it instead. We're going to write it y equals kx. Y equals kx. So the y is by itself. Remember, the constant was 0, so there is no constant. And what x is being multiplied by is called a constant of variation. And this is all stuff you should have read when you were SQ3Ring the lesson for today. In reality, k is the slope. It's what the rise over run is for that linear relationship. So constant of variation. Okay, let's just explore a situation that might be direct variation. If there are 5 people in a room, each wearing a pair of shoes, what would the total number of shoes be? And how would we get it? 10. It would be 10. What do you do? Just multiply what by 2? People. Number of people, because if you should be wearing a pair of shoes, not Aaron the other day when he had on one shoe and the other one was laying on the floor. He still had a pair of shoes in here though. So 10 times, or 5 times 2, altogether there would be 10 shoes. Not pairs of shoes, there would be 10 actual shoes. Okay, what if there were 10 people?
Be 20 shoes.
Be 20 shoes, because of course you're gonna now take 10 times 2. What if there are 15 people? 30, because now 15 people each having a pair of shoes, we're going to have 30 shoes altogether. So what's happening here? The total number of shoes, I keep asking you how many shoes would there be. The total number of shoes in the room varies directly with what?
The x value.
Well, what controlled the situation here? Not independent variably. The number of people. Yeah, the number of people. So the total number of shoes was dependent upon the number of people. It varies directly with the number of people. So all I have to do is tell you how many people there are, and the fact that there are 2 shoes in each pair, all you have to do is multiply by that 2, and you can tell me the total number of shoes. based on the number of people. So how many shoes there are total is going to vary directly with how many people there are, okay? So each time we multiplied the number of people by 2 to get the number of shoes. Each time, nothing else had to be done. That's all we had to do was just multiply by that 2, and we were able to arrive at the total number of shoes, okay? So let me scroll down a little bit so you can catch up there, Riley. Okay, well what if, back in the closet back there, I say there are 2 pair of shoes. You know, some days I just don't like, in the morning I think I like the shoes that I have on, and I get to school and decide, no I don't, so I keep a couple of extra pairs in the closet so that, you know, I can change if I want to. Now, does the number of shoes in the room vary directly with the number of people?
No.
So if I say, how many of us are in here today? Let's see, there's 4,
2,
5 more is 9,
Stack on.
4 more is 13. How many shoes are in here today?
13.
13 people,
26 shoes.
26 shoes. Okay.
Plus 4.
If Riley hadn't come back yet, there'd only be
24.
24 shoes because it'd be 12 people times 2 shoes. But what if I have those 2 extra pair back in the closet?
28.
Or if I really do have?
28.
Then there's 20, there's 13 of us in here right now.
15.
So there's altogether 15 pair of shoes because I have 3. So we have to add 4 more for those ones that are in the closet. So now 13 times 2, but then we still have to add that 4. It's now up to 30. So if somebody else walks in the room, Mr. Larson comes up to visit us, and I say to you, you know, there are 13 of us here, and he walks in, and let's forget about the shoes in the closet, and I say, okay, class, how many shoes are in this classroom now? You would say
14
28, because 14 times 2 is 28. But then I open my closet and you say, wait a minute, there are 2 pair of shoes back there. Now you can't say just because there's 14 people in here, there's 28 shoes total. We have to add that other 4 to it. So when I put 2 extra pair in the closet, now we can't just take the number of people that are in the room and multiply by 2. Because we have to add in those extra ones. So whenever you have to add in extra or take away, now you've lost the direct variation relationship. How could we represent this one, that no shoes in the closet? How could we represent that as an equation? The total number of shoes varies directly with the number of people. John?
Y is equal to 2x.
Y being the total number of shoes, Y, the total number of shoes, varies directly with the number of people. Take 2 times the number of people because every pair of shoes has 2 shoes in it. So what is our constant variation in this situation? What's our K value?
2.
2. K equals 2. What do we have to multiply by the x by becomes our constant of variation. Okay? So, if there were those 2 extra pairs sitting in the closet, would this still be direct variation? What do you think?
Yeah.
Remember, direct variation, the only thing you do is multiply the independent variable by something and it takes you automatically to the dependent. So is 2 extra pair of shoes sitting in my closet back there going to keep this a direct variation equation? No. How would it change?
It'd be
Because that'd be addition.
What would we have? Y equals
2k plus 2.
not 2k, 2x plus 4. Yeah, we'd have to take 2 times the number of people in here and add those 4 extra shoes. So it is not direct variation. The equation would change to y equals 2x plus 4, and we can't have a constant in there other than 0. Okay, so let's go to the back side. This is what you should have already done some of in your SQ3RI, being able to identify direct variation from some ordered pairs. So you don't have a graph, you don't have nobody telling you what the ordered pairs are representing. There are two methods you can use, one of two methods. We're going to practice both of them in your notes, and then you get to pick which method do you want to show when you're supporting your answers in your homework. So the first method, it says, we have two problems we're going to do, A and B, and it says method 1, write an equation to model the ordered pairs. Remember when we used to, or back when we were figuring out function rules? What do you have to do to x to get y? So can you tell me in that first one, A, and can anybody pick out, what do you do to x that works every time to get y? Multiply x by 3. Okay, so let's write that down. Multiply x by 3 to get y. Multiply x by 3 to get y. Works every time. 2 times 3 is 6, 4 times 3 is 12, 5 times 3 is 15, and 8 times 3 is 24. So what equation how would that look in an equation? Multiply the x by 3 to get y. So, yeah, y equals 3x, right? Y equals 3x. What do you think? Is that direct variation?
Yes.
Okay, because why?
There's no other constant.
There's no other constant. In fact, what would our k value be?
3.
Our k value would be 3. Now, let's, though, stay on that one and let's use method number 2. Maybe you were that one that said, you know what, that never worked for me. I could never, or it had to be pretty easy for me to be able to figure out the function rule. Maybe you can't do those function rules very well. Then what you can do is you can set up a y over x ratio for every ordered pair and divide it out, and if you get the same ratio every time, then you would say it is direct variation. So let's try it. Y over x for the first one. And you need to show this in your notes because if this is the method you choose, this is what you're going to do. Y over x. So we have 6 over 2. That equals 3. We have 12 over 4. That equals 3. We have 15 over 5. That equals 3. And you have to show for all of them that it's actually working for all of them. 24 over 8. That equals 3. So every time we got the same constant, our ratio divided out to be the same. So we can see when we write it in equation form, it's direct variation. Or if we get the same constant here every time, we could say it's direct variation. So we would say yes with k equals 3. So this is a direct variation, and whenever you do say it's direct variation, you identify the constant of variation, which happens to be 3. So when you divide it out, and you get that same thing, that's your k value. When you use an equation form, and you decide that it is, it's what x is being multiplied by. Aaron?
Can we go through method 1 again?
Okay, so we're going to do it for the other table also. So will that help maybe when we do it again there? Okay. So let's do B. Let's look at that one. What can we do to x in that one that will get us the y every time? Subtract 3.
Yeah.
8 take away 3, 5. 7 take away 3, 4. 4 take away 1, 3. 3 take away 0. Or 3 take away 3, excuse me, 0. So subtract 3 from x to get y. Subtract 3 from x to get y. That's our function rule in words. So then what would that look like as an equation if we're using the equation method here? What does that equation look like?
X minus 3 equals 1.
Okay, so I always start with the y. Y equals x, take away the 3. How are you feeling about that? Does that look like a direct variation equation? Why not? Because you're subtracting a number. You have a constant in that one, don't you? You're subtracting 3 If you weren't subtracting 3, and it was just y equals x, then we could say it's direct variation. Or, you know what, let's do this. Let's put that 3 over on the other side so that it's in standard, or not that 3, excuse me, I meant the x. Let's put that x over on the other side so it's in standard form. And we can see, we're going to subtract x from both sides. So we're going to have, let's change this, it'll be a negative x plus y, standard form, equals, and this would be a negative 3 left over here. So when it's in standard form, ax plus by equals c. C has to be what? What does c have to be?
X plus y.
What is the c, the constant have to be? Has to be 0. Is it 0? No, it's negative 3. So our c value is negative 3. So that is proving that it is not direct variation. Let's see what happens then if we do the other method, the y over x method, okay? So y over x, we'll start with 5 over 8. Okay, we're going to divide these out so we can see if they match or not. What is 5 divided by 8? Anybody happen to know?
Not off the top of my head.
Okay. Can you compare fractions without dividing them out to decimals?
Yes.
Okay, let's try it then. Next one, 4 over 7, excuse me, not 7 over 4, 4 over 7, right? 4 over 7. Are 5/8 and 4/7 the same value?
No.
Okay. What's the next one?
4.
So 1 over 4,
Yeah.
1 4. Is that the same value as either of those?
No.
No. So what's happening here? And the next one is 0 over 3. Well, 0 over 3 we can simplify. What's 0 over 3? 0. Okay, do we get the same constant every time? Nope. No. So we're going to say not direct variation. And if it's not direct variation, we can't identify a k value because there isn't one. So this one does not represent direct variation. Okay, so we are going to not have to identify the k value because of it not being a direct variation. So when you use the equation method, you have to have, what happened to that? Where did that disappear to? You have to have an equation that supports that it's not direct variation. Here you would say c does not equal 0. And this one, if you're going to use the y over x method, you have to show what are the yx over what are they, and show that they're not all the same. So you're going to use one method or the other. You do not have to do both. We just practice both. Okay? So anybody have questions about being able to determine if a set of ordered pairs that may be linear, whether that linear relationship is direct variation or not? Okay, then let's go on to the last thing here where you have to write and solve direct variation equations with some given information. It says right here, if y varies directly, in other words, they're telling you y is going to vary directly with x, and you were given at least one ordered pair for the relationship, so in other words, they give you just 1 point, that's all you need, because remember, if it's already been determined it's direct variation, y over x actually equals your k value. That's your k value. So you can put the y from that ordered pair over the x, and you can get your k value that way. And then you can write the equation for that relationship that'll help you solve for the missing information. Okay, so given that y is 4.5 when x is 0.5, what should we do? We need to find the k value, which will help us write our equation.
K would equal 4.5 plus 0.5, or y plus x.
No, y, not y plus x, y, no y divided by x, y over x, like we were just doing up above when we were looking to see if there was a k value. So we're going to do k equals y over x, which will be 4.5 over 0.5. So that's really asking us how many halves are there in this number. How many halves are there? This is not working. You're not following one. How many halves are there in 4.5? 9 of them. So K equals 9. So the first thing you would do, they tell you it's a direct variation relationship. All you need is one ordered pair where you can put y over x, divide it out, get your K value. Now you can write your equation for that relationship. So what would our equation be for this one? Remember, direct variation is y equals K of x. Did anybody ask Q3R less than 4.5?
You multiply K times the X to find Y.
Okay, so what would that equation be? You multiply the K times the x to get the y. What would that equation look like?
9 times 10 is equal to
9 times what?
10.
No, 9 times, I want the equation for the whole relationship. Y, 9 times x equals, y equals 9x. There's our equation for this direct variation from which that ordered pair came from. So that is the equation for that linear relationship. And now we can say, okay, if I know the equation and I have to find y when x equals 10, I can put 10 in for x and I will get my y. So what's the y value? 90. And vice versa, they would have said to us instead, what's the x value when y equals 90? We could have put 90 into that equation for y, and we could have solved the equation for x. So we'd have 90 equals 9x.
Right, how'd you get 10?
Because it says it right here, we're looking for y, right there. It says we're looking for y when x equals 10.
Oh,
So all of this was preliminary work to get the equation that we needed. And then once we had the equation, we could use it to find what they really wanted us to find. Okay? So you're going to have to do some preliminary work first to get the K value, which will help you set up the equation, which then you can use that equation to solve for either the x or the y from another point, whichever one they're asking you to solve for. Should have been doing some of that in your SQ3Rs. Any other questions?
Levi Hammack to the senior high office, please. Levi Hammack.